Now, remember that the weightings of your topics per grade 12 question paper for functions and graphs, it will count about 35 marks in total of your 150 marks. So along with differential calculus, this is going to be one of the topics that counts the most for paper 1. Now, when we start taking a look at question 5 from your June exam paper, it starts off by saying the graphs of f of x, 2x, 2 bracket x plus 1 close bracket squared minus 8 and g of x equals to a half to the power of x are represented in the sketch below. Now immediately you have to remember that whenever we have something squared, it's normally the parabola function, and if we have something to the power of x, it is normally our exponential function. Now we have revised the different function formulas in some of our extra classes and so these should be second nature to you at this point. If so not, you're going to have to go through this again and make sure you know all the characteristics of each function. Now it also continues in the information that P and Q are the x-intercepts of f and R is the turning point of f. A minus 2, 4 is a point on the graph. Now, the very first question asks you write down the equation of the axis of symmetry of f. Now in this case, f will be my parabola, and for a parabola, the axis of symmetry is always at the x value of the turning point. So therefore we know that x will be equal to the negative p value in this case. Therefore x, or the axis of symmetry, will be where x is equal to minus 1. Now this p value comes from the fact that we have our parabola's equation in the form of f of x equals to a x plus p squared plus q, in which q shifted the function up or down, and it will also give you the y value of the turning point, and then your p value shifted your function left or right, to the positive side if it's negative and to the negative side if it's positive, and will also give you the x value of the turning point. Okay, then the next question asks you write down the coordinates of R, the turning point of F. Now like we just said, if we have the parabola in the parabola's equation in this shape that has been given to us, we can say, okay, but the coordinates for the turning point would be at negative p q. Therefore we have, it's good that the turning point will be at negative 1 and negative 8. Okay, so far just reading from the graph and then finding some information from there. Okay, the next question then asks, okay, now determine the coordinates of P and Q. Now if we take a look at the sketch given to us, P and Q are both points where the parabola intersects our x-axis. So therefore we know that these are going to be x-intercepts. And at our x-intercepts, our y value is always 0. So therefore we can say, okay, to find P and Q, we just calculate the x-intercepts and we make y 0. So therefore 0 is going to be equal to 0 is equal to 2x plus 1 squared minus 8. Now there are two ways we can solve this. I'm going to go with the simplest way. We can throw the negative 8 over, then it becomes positive 8. So we have 8 equals to 2 to the power or 2 times x plus 1 squared. Then from there I can divide on both sides with 2 so that I can get the bracket that is squared alone. Therefore we have 4 equals to, these two can cancel each other out, and we're left with 4 equals to x plus 1 squared. From there I can then take the square root on both sides to get rid of the to the power of 2. And remember, if we take the square root, our answer is technically plus minus 2 equals to x plus 1. And then from there we can say, okay, but x is going to be plus minus 2 minus 1. Therefore, x is going to be 2 minus 1, or x is going to be equal to minus 2 minus 1, and x is either 1 or x is equal to minus 3. Therefore, we can say, okay, if we take a look at the point Q, it seems that our x value must be positive. So our coordinate for Q will be, we're at x 1, 0. And if we take a look at P, it seems like our coordinate must be negative. So we can say, okay, but P is going to be minus 3, 0. And that would have been one approach to get it. Now I'm quickly going to do the other way we could have done as well to find this, but both of them include calculating the x-intercepts. So for the other approach, we could have said, okay, but the x-intercepts are going to be where y equals to 0. Therefore, 0 is equal to 2 times x plus 1 squared minus 8. And now instead of throwing the 8 over, I'm going to expand the bracket. So then I have 2 open bracket x squared plus 2x plus 1 minus 8. Multiply the 2 in. Then I have 2x squared plus 4x plus 2 minus 8. I multiply the 2 with everything inside of the brackets. Then I can simplify. So then I have 2x squared plus 4x minus 6, because 2 minus 8 gives me minus 6. Then I can divide straight through with 2 to simplify a little bit. So 0 is then equal to x squared plus 2x minus 3. And then from there I can simply just factorize like I would normally do. So 0 is then equal to x minus 3, no, x plus 3, x minus 1. And then from there I can say thus x is equal to minus 3 or x is equal to 1. And by using the same reasoning that we use for Q and P with the red example, we could then say, okay, but Q looks like it is going to need a positive exponent. So Q is 1, 0. And then P, apologies for that background noise. And then P is going to be minus 3, 0. So that was what we needed to do there. Our next question then asks, okay, now we know that g of x is equal to a half to the power of x. So the very first question, determine the equation of g to the power of negative 1, the inverse of g in the form y equals 2. Now remember that if we find the inverse, this is the reflection of the function around a y equals to x-axis, and to find the inverse we simply just swap the position of x and y around. So we know that g of x is equal, or g of x tells me that y is equal to a half to the power of x. So therefore if I find the inverse, g of x will be equal to x, or will tell me that x is equal to a half of a power to the power of y, because we just swap x and y around. And in this case we will need to use a log. Now remember, the log said that if I have something like a to the power of x equals to n, I can use a log. Then the a becomes the base of my log, the n goes into the log itself, and my exponent then becomes my answer. So then I can say y is equal to log of a half x. And that would then be your answer there for 2 marks. 5.5 then asks to sketch the graph of g to the power of minus x in your answering book and clearly indicate the intercepts with the axis and at least one other point of g of x. Now, one thing to note that for all the points of the inverse of g of x, it will just take the coordinates of g of x and swap them around. So if the coordinate, for instance, let me show you, let's say for instance g of x had a coordinate of x, y, then if we take it to g to the power of minus 1x, which is the inverse of g of x, then my x and my y's just swap around, so it becomes y, x. So in actual fact, we know that one point on g of x that was given to us was minus 2, 4. So that means on g of x, they will just swap around. So we have 4 minus 2. So that would then be a point on the inverse of g of x. We also know that g of x intercepts the, since it's an exponential function, it intercepts my y-axis at the coordinate 0, 1, because there was no translations. And if there's no translations, the exponential function always has a y-intercept at 0, 1. So we know that that's another coordinate on g of x. And if it goes to the inverse of g, then the coordinate just swaps around. So that means we know that, and I'm going to do this to represent it nicely now, if my exponential function is the one in orange, which I hope you can see, if that was my exponential function, then I know my inverse is the reflection around the y equals to x line, which is the green dotted line that I've drawn in now. So then I know from that that my new function, if it's reflected around that line, will look something like this. And then I can say, okay, but the x-intercept will be 1, 0, and then my other point on it would be at 4 minus 2. Okay, because we just take, since it's a reflection around the y equals x axis, all my x and y values just simply swap around. So let me just fill that in there as well. So there was 0, 1, and then somewhere there it would have been minus 2, 4. Okay, then question number 5.6 asks you, okay, now for which values of x is, now they ask you for 5.6.1, where would g of x, okay, meaning where would the answers that you get for g of to the power of minus 1x, the inverse of x, be greater or equal to minus 2. So if we go by the function, we know that we just drew it and it looks something like this. So there it would be 1, and then somewhere here we'll have the coordinate 4 minus 2. Yes. And then from there, we now just need to determine, okay, where will the inverse of g always have an answer greater than minus 2? Now, if we go to the area that I'm coloring in green now, my y values are just going to keep getting smaller and smaller and smaller. So my answers for my inverse will be smaller than minus 2. And if I go to this area with the light blue, okay, my answers for x, for y is just going to get larger and larger and larger. So that means for g of x to be larger or equal to minus 2, I need to work with all the x values on this side of this coordinate, okay, of the 4 minus 2 coordinate. Therefore, we can say x must be smaller or equal to 4, but it will never be able to become 0 because of the way the logarithmic function is set up. So x will be between 0 and 4. Then for 5.6.2, in this case it asks me where if I take the value of x and I multiply it with the value of f of x, will my answer be smaller than 0? So remember, if we talk about f of x, that's just a fancy code word we can use to talk about y. So in a sense, where does the x value that I have, if I multiply it with the y value I got from f of x, give an answer smaller than 0? So that would mean that one of them needs to be negative while the other one is positive. So if we take a look at the values between or before p at this side, which is now red, over here, we know that my x values are negative, okay, but my function f of x will be positive. So that means if I multiply those two answers, it will always give me a negative answer. So all my points before p is applicable in this case. Then from p to o, this point over here, let me use that a different color, my x values will be negative, but my function f of x will also be negative because it's below the x-axis. That means it's going to be a negative times a negative, which will give me a positive, which does not satisfy the inequality that I have. Then we have that between, let's use another color, between O and Q, we have positive x values, but my function of f of x will be negative. That means a positive times a negative, so that is also a situation which satisfies my inequality. Then lastly, we have this part over here, in which f of x will again be positive, and my x value is positive. Therefore, the functions, if we multiply those two answers, it will give me a positive answer. So at the end of the day, I'm allowed to work with any x values that's on this side and any x values that's here in this little intersect over here. Therefore, x must be, now if you remember correctly, the x value at p was -3. So x must be smaller than 3, or your x value at O will be 0, and then the value at Q, which we calculated, would be 1. So x needs to be between 0 and 1, or it should be smaller than -3. And with that, ladies and gents, that is question 5 from the June 22 exam paper. And now remember, work hard and stay bumble. And I do hope you are able to prepare and are starting to feel a little bit more comfortable with the mathematics before the prelims and the finals.